Right, hi everyone. Welcome to this wonderful technical workshop as part of our Bounties for Bandits series. Program, overriding program. We're delighted to have the Saddle team with us to give you through a technical introduction to everything Saddle, which should form an essential part of all of you if you're doing one of the technical bounty challenges. Or if you're still just considering. So if you have any questions during today, guys, please put them on the chat. Vanessa is going to be putting in some general links. Some of you have already registered and are part of the program. Some of you maybe are still to register. Some of you decided what you want to build. Some of you are still deciding, all of which is absolutely okay. If you do have any questions, guys, put them in chat. But we're going to go straight to the Saddle guys who can talk you through everything that you might want to know about Saddle. We have Sunil, the founder. We have David and John Lim as well, who are going to talk you through everything. So without any further delay, Sunil, I guess I hand over to you to talk us through everything Saddle related.
Yeah, for sure. Thank you so much, Anthony. Always a pleasure. So a little bit of background. I am Sunil. I'm the founder and CEO of Saddle. A little bit of background about the protocol for those who haven't maybe done a little bit more research. We are an automated market maker for peg value crypto assets. The protocol was first launched in January of 2021. Since then, we've done a little bit over $800 million in cumulative USD volume, and I think their protocol is currently sitting at around $270 million in total value locked. I'm here today with two of my teammates, David Ham and John Lim, who will be able to give us a little bit more of a detailed walkthrough of our code base. So we're mostly using TypeScript and Hardhat on the Solidity side of things. And then on the D app, we're mostly like a React and Redux shop. So with that, I'll hand it off to John. Do you want to kick us off with the smart contracts?
Yeah, so we have our code base hosted on GitHub, and I'm just gonna post the link in the chat while I'm just setting my Chrome window up. Yeah, so everything related to our core contract are stored in this repo Saddle contract. And the setup we use is, as Sunil mentioned, we mainly use Hardhat for testing and coverage, and also just general building wise. Those who are familiar with Hardhat, you can probably take a look at the Hardhat config to kind of see what kind of setup we're using for multi-chain compatibilities. We've launched our contracts on Arbitrum as well as some of the testnets, and using Hardhat really helps out here. Just managing multi-chain has been pretty annoying, but with the help of Hardhat, it's been pretty smooth. For the smart contract stuff, we are storing in the contracts folder. And as you can see, we have a lot of moving parts here. The reason why we have a lot of contracts is because a lot of math-related functionalities are quite dense. And because each contract has a limit on the size of how much data can be stored, we have it split up into using libraries, and the core contract actually does not have the math functions. All the math functions related to the swaps or stuff like amplification, which matters in terms of how efficient a swap should be. Those are stored in different libraries. And you can see this is one of the libraries called amplification utils. Just gonna zoom in here. We also depend on Open Zeppelin libraries, and those are always helpful because they've been audited, they're battle tested, and usually it's a great source for learning as well. If you're not too familiar with Solidity engineering, I would highly suggest checking out Open Zeppelin. It's great. So here we have a lot of functions relating to the amplification part. And you can see how we have checks for changing the A, which stands for amplification, stopping A. And we also have a library for the actual swap functionalities called swap utils. And this is where the actual math happens for automatic market maker math, or otherwise known as stable swap, and uses Newton's method to kind of calculate through 2 or 3 iterations. I think I've seen up to 4, but usually it gets solved in 2 or 3. I think this is a quite bit of dense math, so I'm not gonna get too deep into it, but basically we use a iteration method to solve what the price should be for a given token. Say we have a pool of two different tokens, and we want to calculate like where the peg should be, assuming that the two tokens are equally valued. And of course, given the market changes, like say we're pulling USDC and USDT, there could be a little bit of a premium on USDT or USDC at a given time. And using this Newton's method to find out that equilibrium given the size of our pools is really helpful because it always gives you an efficient swap. So we have different functions that dealing with adding and removing liquidity as well, which also uses the iteration method to calculate how much of the LP token the user should be, the depositor should get in return. Of course, if you're providing assets in an imbalanced way, or say you're providing an USDC to an oversupplied USDC pool, you're gonna get less than what you put in, right? Or if you provide an asset that's scarce in the pool, then you're gonna get more than what you provided. And it works the same way as a swap, essentially. And we have different view functions to calculate for the front end, so the users can see how much they will be getting. And it's the same thing as the actual swap. It just runs the simulation and as a view function, and it returns the expected value. And the reason why we have these view functions for calculating so-called like a preview value, right? The reason why we have this is because on Ethereum chain, say you wanted to swap 10 USDC to like 9.9 USDT. But if the market condition changes while your transaction is going through, you want to check, you want to have some kind of check so that your slippage doesn't go crazy. So that's why we have these preview functions, and people can define how much the least amount of value that you'll be getting. And I'm sure if you've done swaps on Uniswap or 1inch, you've probably seen the slippage settings, and this is exactly that right here. We also have other auxiliary contracts to enable permissionless pool deployment. So anyone can clone our pools using proxies. And those who are unfamiliar with proxies, those are contracts that use other contracts' data as if it's its own. So the benefit of using proxies here is that you deploy a contract that's one of the smallest size you can deploy, but also contains the data from another contract that's already been deployed. So this way, if you're creating like multiple copies that uses the same structure or the same core data, you can just launch, you can deploy a proxy for that and then just reinitialize it. And this way you have essentially deployed something very cheap, but it still has the functionalities of that expensive contract that you've deployed before. I think this is becoming more and more true as ETH price goes up and gas prices going crazy. We also have different extensions for swaps, enabling flash loans. And you can see we're inheriting swap, but adding a couple of features that allows flash loan to happen. Similar way, we also have a meta swap, which is essentially storing a base swap LP token in a pool and pairing that with our asset, thus separating the risks between the asset that's in the meta swap level and the base swap level. It's also using the swap underneath, but has other libraries that enable the meta swap functionalities. And I think that kind of covers overall architecture of our smart contract side. Of course, we also have the core swap contract that the users actually interact with. And as you can see, it's not too long. It's about 500 lines without any actual math, as the math is done in the library contracts. Cool. Any questions so far?
There are various questions on chat that I think Sunil is also steadily working through as well. But yeah.
We're also planning on deploying to Optimism as well as strengthening our position on Arbitrum. I think definitely we could do some work in building up registry contracts, kind of helping us analyze numbers and also bring everything together. I think Dune Analytics has been really helpful. Actually, let me pass that analytics side to David. I think he's been doing some work for the graph and as well as Dune Analytics.
Cool. So my name is David Hum. I'm the front-end engineer for Saddle. My background is I actually attended a coding boot camp way back in like 2014. It was called App Academy here in San Francisco. Before that, I was a marketing major, so it was like a pretty hard shift in where my focus lied, but that enabled me to get sort of my first software engineering job at Intuit, where I worked for about a year. Then I was at Uber for just under 4 years, and I helped to launch UberEats.com, which was the web-facing side of Uber Eats. Then most recently, I was at Flexport for about a year and a half, and then I joined Saddle about a year ago. And so Sunil and I had met through our Uber connection. So for those of you not familiar, this is what the site looks like. At a basic level, its foundation is a Create React app, which essentially is just like a library that handles all the boilerplate code of setting up React app, handling TypeScript, and just sort of like templating out a structure for you that's like very easy to understand. And like when you go from one Create React app to another, then they all sort of look very similar in their structure. Additionally, we make pretty heavy use of Ethers.js. Essentially, it's just like a Web3 library, and this is what we use for interacting with all the contracts, both like reading and writing, creating transactions, stuff like that. Let's see, it's type safe ready. So it has this really cool feature where basically we can provide ABIs, and we have a library that will take those ABIs and translate them into Ethers.js compatible like types, which is super nice. That way, when we actually like write the contract interactions in code, we can do it type safely, and we know that the return function, the return value is like a big number or a string or something like that. When I started using this library, I think one of the biggest things for me to wrap my head around was sort of the big number library, because obviously when you're doing financial stuff in JavaScript, the base like floating point JavaScript math is like not good enough, especially when you're dealing with like 18-point precision, or stuff like just like random coins like Bitcoin, where like one coin is $60,000, right? You want to be as precise as possible, and so big number just enables that. So reading through here is always something that I definitely recommend. Let's see. Beyond that, this is our GitHub. It's public. Everything is like there for you to read, free and open source. So please do feel free to poke around and create issues or create pull requests if you'd like to. Over the course of our deployment, essentially what will happen is we create a feature branch that gets reviewed by our team. It passes CI, which we do through GitHub. And then once that passes and we merge it into master, which is a manual process, then that is automatically picked up, built, and deployed to IPFS through a service called OnFleek. And we use that as our like hosting solution. So hopefully we can never go offline. So I just want to do a quick walkthrough through like the major features. So as you can see, it's like a pretty, it's a pretty sparse site. Obviously the highlight here is the swapping feature. So we want to be able to, swap from one token to another. And then as we see, there are some options that are virtual swap, some that don't have any of these tags. And then at the bottom, we have some types of transactions that are unavailable. So what some AMMs or exchanges will do is they'll just have like a token list of like, okay, here's the whatever 200 tokens that we have. They'll let you choose any 2 tokens from those. And then once you do that, then they'll tell you if it's, if you can do a trade or not. We sort of went in a different direction. And once you choose your first token, then we like generate the list of acceptable pairs and sort of like what those routes look like. So if I was to go to BTC, we would see that this is a virtual swap, and here's kind of the route. or if we just did like SUSD, we would see this as a direct swap. So this is sort of like two features in one. So this is both like direct swapping, which is, we have different pools of combined assets. So for example, we have one pool, which is, sort of like the primitive stable coins. It's like DAI, USDC, USDT. And so a swap would be like, swapping within those pairs. But we also recently added a feature called virtual swap, which uses synthetics essentially to bridge across pools. So if you had a pool with a synthetic asset like SUSD, you could go like USDC to SUSD to another synthetic asset like SBTC or SF, and then out into ALF or something like that, which involves more hops and is usually advisable only above like a certain dollar amount, just because of the gas fees involved. But yeah, that was a pretty interesting feature to build. These are all of our pools. So again, you can see the combination of these assets, the various APRs and APYs, our TVL, and our volume. So this data comes from a few different places. This page itself just comes from sort of a static list, almost like a token list. I think we'd like to move in that direction in the future, but we sort of have our own more primitive version of that. That just describes basic data about the pool. And then once we render those, then we also pull in data through Web3 from John's contracts that actually tells us, how many of each token are actually in the pool. We fetch prices from CoinGecko to get like the dollar value for those tokens. And then we sort of do some math to display the TVL. And then we also have sort of a primitive APY that we use to calculate the 24-hour volume, which is essentially just like looking through all the different events for all the different pools, and then figuring out the volume. And again, using CoinGecko to pull in the prices to get the USD volume. And from the volume, we sort of infer the APY for this 24-hour window. So if this volume happened for the next 365 days, what would the APY be, basically? And then, of course, you can sort of filter by all the different types of pools here. Additionally, once you click into a pool, we have some basic information about the pool sort of expanded, right? So in addition to the pool's composition that we were just talking about, we also have more attributes that, pretty much all of these you could just read directly from Etherscan if you wanted to, with the exception of like utilization. We also read the user's wallet, and we'll tell you how much of the pool you own with your LP tokens. And then we also provide the ability to deposit or withdraw, or if you already have LP tokens, stake or unstake. And then because we just launched our token, you can also claim your tokens. All right, I'm going to jump over. Oh yeah, also one other thing I forgot to mention. You can also, switch between networks, and hopefully we'll have like plenty more networks there and switch themes, which is always fun. Jumping over to some code. So if you're going through our repo, our front end repo, basically we have one file, which is source constants index, which is kind of where everything starts. This is where we define the networks that we support. This is where we define sort of like what a token looks like to us. And then we just go through and we sort of like build out all of these definitions. We'll be moving these to a static file sometime soon, but for the time being, once John or Sunil deploys one of these contracts, for example, like one of our swap contracts or a meta pool or an LP token or anything like that, we pull in the addresses and put them here so the front end can reference them. And then we aggregate these. Let's see if I can scroll here. We aggregate these into a series of pools, which again, just like has all the basic information. So like, what is the name of the pool? Where can we find it? What's its LP token? Is it synthetic? And that's sort of how we do some of our routing logic. And then also what kind of pool is it? And that helps us get like price comps. Moving along, again, this is just a React app. So it has sort of like the basic top level app page. So our component library is sort of divided into pages, which are like the top level pages. As we see, we have like the app, which wraps everything, deposit, pools, risk, swap, withdrawal. Those are our major pages. And then we also have, just like our discrete components, which are theoretically composable. We build up our routes. We use React hash router. And so we go through our pools list and just build up routes for each pool that we support so people can navigate there. We use Redux a little bit. So we primarily use Redux for like advanced options. So for example, if you wanted to change your slippage or you wanted to just automatically turn on infinite approval whenever you do an approval flow or set a transaction deadline, we store that in Redux. And then that actually gets persisted via local storage. So whenever you come back to the app, then you don't need to like re-change your preferences. They're just exactly where you set them. But a lot of other things we just use React State or like providers for. And going through some of our sort of like more major parts of code, one of the bigger hooks that we have and one of the ones that we use most prevalently is the use pool data. So essentially this just contains the state for a given pool. And it does that by, so essentially you give it a pool name. That's sort of like the dominant way that or the primary way that we refer to pools instead of by addresses or anything like that. And so given a pool, it just like fetches a ton of data about that pool. So it'll go through, it'll get the LP tokens, it'll get the user's LP token balance. It will get third-party data for the pool, which includes like APRs and like if you have your LP token staked elsewhere, right? So we have partnerships with like Alchemix and various other protocols and like Frax, for example. So you can stake your saddle LP token on their site to earn APR or APR with them. And so we want to make sure that we're pulling in that data and rendering that correctly. And then we go through and we basically just make a bunch of calls, do a lot of math. It's kind of a lot. And then at the end of the day, we put it all together into a pool data object that just tells you again, like the basic read things, like what is the A parameter, what's the amplification value, volume, etc. And then some of our, sort of more active hooks is, for example, use, approve, and swap. So you give it some state of a transaction, and then it sort of does some validations to make sure that your state is valid. It starts an approval flow, making sure that the app has permission to actually do the swap. And then because we have all these different types of swaps, which I'll talk about in just a second, there's sort of like different argument structures because there's different types of functions to do these different swaps. So let's jump into that really quickly, and maybe I'll come back to this. So as I mentioned, we have different types of swaps that can be performed, right? So we have direct swaps within a pool, and then we have virtual swap, which is outside of a pool. But within sort of the virtual swap class, there's actually, let's see, what is this? 4 different types of virtual swaps that you can perform. And to get a really quick look at that, this is basically what it is. So token to token is basically like going from a non-synthetic token through a synth, through another synth, into another non-synth token, token to synth to token, and then synth to synth. And so those are all sort of different methods. And even in this last case, a different contract that we use to perform this action. So as I mentioned earlier, we sort of do this unique thing where we display the valid set of pairs of like trading pairs as soon as you choose your first token, instead of waiting for you to choose both and then telling you that that's invalid. So because this is like a little bit memory intensive, or like could be in the future computationally intensive, we just use like a sort of simple cache that we read from. And so we say, if we've seen your input token and the chain, then we know what the output is. We already have it cached. It's basically just what this is. And then the logic is essentially, we have sort of our full set of valid tokens and then a mapping of pools to tokens and vice versa, just for easy referencing. And then we are essentially like building up sets and intersecting them. So we're looking for tokens that like share a direct pool with our given token, or things that are connected through synthetic tokens. and then we just iterate through each token. And we essentially say, we just have a set of cases, right? We say, if it's the same token, then it's invalid. Our default case, right? Like our default sort of swap data for this pair is that it's invalid. If it shares a pool, then it's a direct swap. If we are disallowing virtual swap, for example, on Arbitrum, virtual swap is not enabled yet, then we fall through to the invalid case. And then again, just the logic for handling different types of synthetic swaps. So if our input and our output is both synthetic, then we're doing a synth to synth. If one is and one isn't, then we're doing a synth to token. And we just sort of go on through like that. And so jumping back to the user proven swap function, if we have all these different types of swaps, then that changes sort of the arguments that are required for the contract. And so we just have an else if, where we iterate through all these different types of swaps that we support somewhat cleanly. We build up our arguments array, and then we just dump it into the correct contract function. So again, here you can see one of those types we talked about earlier, where it basically just translates the ABI over to TypeScript. And so that way, as we're typing in our IDE, we have this really nice functionality where we can just do, like .a, and it'll say, oh, approve. Here's all the arguments that you need. Yeah, and I think that's a pretty decent high-level overview of our app. Sunil, would you be interested in talking about either like our Dune dashboard or our little API that we threw together?
Cool. So Dune is a really awesome service that lets you basically, let's jump into one of these guys, write SQL queries and basically visualize results in like either tables or top level numbers for basically tracking KPIs. So this is our current Dune dashboard. The main things we're tracking are some of the things that I mentioned earlier. So total value locked in the protocol. This doesn't include Arbitrum and some of the newer pools. So if folks are looking for potential projects, we could definitely use better analytics. Almost pushing around $900 million in cumulative USD volume, and tracking just the number of unique deposit addresses that have interacted with any of our contracts. We have statistics for pool composition over time. So this would be the original BTC pool that we launched in January. As you can see, it kind of tapered off. And then at the beginning of October, we launched a new version of the pool with gas optimizations and whatnot. So you can see TVL kind of migrating to the newer pools. So we have the same sort of visibility for a bunch of the pools we're launching, as well as weekly USD volume. So we've generally been pushing around $20 to $30 million a week in volume. Same sort of thing broken down by asset, as well as trades per day and weekly USD fees.
So do you want to talk about B4B and maybe Project Senpai? I don't know if you're allowed to.
Hey, yeah. Let's see. So I think everybody is already familiar with B4B. I assume that's why you're here. And if not, I believe Vanessa has posted videos to the info session. And yep, for one of the project categories, the very first one actually in the technical track is, which Sunil is referencing as Project Senpai. It is to fork Saddle's code onto other chains. And I did see a question about which other chains, so any EVM compatible chains. And basically Senpai stands for Saddle Ecosystem Max Proliferation Initiative. And you're invited to take part and take the code that John and Sunil and David has kind of roughly overviewed, and to create basically a saddle fork on any of the other chains. And in addition to the Bounties for Bandits bounties for this project, we also have an extended grant for promising projects and teams just to provide continued support, and also incentives beyond just the saddle tokens and the bounties. So yeah, I think that covers the big pieces. And was there anything else? I guess we can go into some questions.
Yeah, there's lots dripping in on chat. So a lot of them have been picked up. It might be worth saying the best ones out loud. Someone just asked about license. The license, which obviously has a little bit to do with forking onto other chains as well.
Should I just run through some of the questions then, Anthony?
Yeah, I think it might be useful.
For sure. Yeah, so all of our code is licensed using a very permissive license. So folks are free to reuse it, deploy it to other chains, modify it, et cetera, et cetera. So the specific license is listed in each repository, but it's the MIT license. Some other questions were about how other assets are going to be added to the protocol and what is the process for adding those assets. So we just launched a governance token for the protocol in the last few weeks, and we've set up a proposal process. So the main flow of how things will look like is folks will submit a proposal on our discourse where there will be a soft poll done on the forum. And then if that has a simple majority, it'll go to a vote on Snapshot, which will actually enable, holders of the SDL token to vote. And then if the Snapshot vote passes, the community multi-sig will effectively deploy and launch whatever the community is voting for. The SDL prizes as part of Bounty for Bandits are vested, I believe, Zim. Is that correct?
No, I believe they're available immediately. Yeah, just like liquidity mining incentives, they should be available immediately and subject to the lockup, of course.
Challenges about bug and security reports, but it says the prize is discretionary. Yeah, if you look at our Immunify bounty program that Zim launched, they basically have a classification system for how do you determine the payout given a particular severity bug. Do you recommend TypeScript? Absolutely recommend using TypeScript if you have to work with JavaScript, which is very hard to avoid in Web3. It just makes life a lot easier, having stronger typings versus having to deal with what is this object? Yeah, David, do you have anything to chime in there?
Yeah, I mean, over the course of my history of being a web dev, yeah, I've gone from regular JavaScript to Flow to TypeScript, and I think I definitely prefer TypeScript the most. It's one of those things where it's much easier to start a new project with TypeScript rather than try and retrofit it in or try and use something like Flow. But yeah, I mean, just to have that complete coverage is definitely worth the the very occasional times where you'll have to fight with it to correctly type a reduce function or something like that.
Sweet. Yeah, we were pretty lucky because since this is a more recent project, development started in the middle of 2020, we were able to use a lot of the newer tools since we were just getting started from scratch. So working with Hardhat has been absolutely fantastic. Yeah, John, do you have want to provide a little more color there?
Yeah, I know if you've been looking to tutorials on Solidity, you might have seen tutorials using Truffle or other testing suites, and Hardhat basically combines all the features that people want to use regarding testing and deving, including you can fork the current chain to see what the results would be. Certain manipulations happen, so those are really great for testing for accuracy and potentially security issues. And let's see, there's console access, so you can access any local chain that's been running to modify or see what's the data is doing there. You can also use Mocha, any kind of testing suits. It handles deployments per chain. Yeah, it also handles Etherscan Verify as well. So it's just probably the one most important tool if you're trying to get into Solidity development. And Viper too.
Cool.
Do we do the subgraph question?
Yeah, so we have an existing subgraph. I will drop a link to the repository in chat. But it can definitely be improved if folks want to start from scratch. There's definitely a bunch of refactoring that can be done to just clean up the code and whatnot.
Very good. Any other questions?
Vespa had a question about what kind of protocol development we wanted to see.
Yeah, at least in terms of core protocol development, that's totally up to the community. If there are things or improvements that you guys want to see, we are making ourselves completely available to help, whether it's answering technical questions or pointing you to particular points in the code and whatnot. But for the core protocol development, the like version 1 of the Saddle protocol has been audited and is successfully deployed. So we aren't planning on doing any major work on that particular piece. Stuff that is coming up is we'll be working and thinking through how token economics can actually look like, as well as what adding fully on-chain governance to the protocol would look like using the compound governor Bravo.
Excellent.
We're also interested in adding more sort of like dashboard tools for users. So as our token becomes more prominent, tracking the amount of like profit and APY that is earned via Saddle. Additionally, fleshing out our subgraph would definitely be super nice. Adding more functionality to our API could also potentially be good. Stuff like that. Also, having more like Dune dashboards or like analytical abilities sort of from a competitive perspective, right? Just like tracking our health as an AMM in the market is also something that I think is not a direct feature, but is like totally valuable as a protocol.
Yeah, and as Sunil mentioned, all of our code base are licensed with MIT license. So everyone is free to fork it, test it out. And if you're having any trouble, feel free to jump into our Discord. We'll be able to help you out. And of course, if you're also trying to build for B4B, feel free to join the Discord. You can build a strong community.
Awesome. Anything else you want to say, Saddle team, before we close up?
I just want to say thank you, Anthony, and the entire Encode Club team. It's always a pleasure working with you guys. These events are fantastic. Thank you, everyone, for watching. Please hop into our Discord, follow us on Twitter, Saddle Finance. And yeah, if anyone has any questions, feel free to just pop in, drop a question in Discord, and we will be there to help.
Awesome. Well, you stole my thunder because I was going to thank you guys. So thank you all around. Thank you, Saddle. Thank you everyone for coming and taking part today, listening. This will go up on YouTube tomorrow and be sent to all of you who signed up and who participated today. Look forward to seeing what you build in B4B. In the meantime, guys, have a very good evening, afternoon, morning, wherever you are. And we'll see you all soon and look forward to good stuff being built. Thank you very much, everyone.